direct and inverse variation equations, and we'll be solving these word problems using this. If something varies directly, then we will use y equals a constant times x. If there is an inverse relation, we'll use y equals a constant times 1 over x. It says here, the volume of a sphere varies directly with the radius cubed. The volume of a sphere varies directly with the radius cubed. So this is the direct variation. So we're going to use y equals a constant times x. Now what they're using for y, they say the volume of a sphere varies directly. So this is volume. So we'll say v equals, and then the constant. Varies directly with the radius cubed. So I need the radius cubed for x. Radius cubed. All right, so this is our equation. Now v equals a constant times radius cubed, and furthermore, the volume of the sphere is 13.5, while the radius is 1.5. So the volume is 13.5 equals k times the radius. I'm going to use a parentheses this time. 1.5 to the third power. Okay, so I need to find out what 1.5 to the third power is. So I'm on my calculator right now, figuring out 1.5 to the third power. And what I'm finding is that we'll get 3. Okay, sorry, the 13.5 needs to come down, the k needs to come down, and this becomes a 3.375. Okay, so I'm going to take 13.5 equals k equals 3.375. I'm going to divide both sides by the 3.375. So 3.375. Now from here I'm going to use my calculator. I know this simplifies down to just k, but I'm going to type in 13.5, and then I'm going to divide that by 3.375, and we're going to get nice little number, 5.065. So that's our constant. All right, let's go back here, and we're going from v equals a constant times r to the third power to v equals 5.065 times the radius to the third power. Okay, so we'll be using this. Finally, what would the volume be if the radius was 1 meter? Oh, that's nice. Okay, we can do that easily. So v equals 5.065 times 1 to the third power. Well, 1 times 1 times 1 is still 1. So we'll get 5.065 multiplied with a 1, and we get 5.065. Now, just unit-wise, the volume is measured in meters cubed. So this will be meters cubed as a unit. Okay, to preserve the volume of a square prism, the height must vary inversely with the side length squared. All right, so this varies inversely. So this will be y equals a constant times 1 over x. Now, y in this case, to preserve the volume, the height must vary inversely. So this is a height problem. So this is height must vary inversely. So inversely with the side length squared. I'm going to use L for the side length, and written in cursive here, and then squared. All right, we have all our pieces. Now, further, the height is 10 yards, while the side length is 2 yards. So height is going to be 10, and the length is going to be 2. So this is going to be 1 over 2 to the second power. Now, 1 over 2 to the second power is actually 1 over 4. So we're going to make this k times 1 over 4. Now, to solve for k, I'm going to multiply both sides by 4. And 4 times 10 gives us 40. And these cancel, leaving us k. So k is 40. So we will rewrite our problem. H equals a constant times 1 over L squared. We're going to write this as H equals k, sorry, not k, 40. 40 times 1 over L squared. All right, so further it says, what would the height be if the side length was 4 yards? So let's make the height equal 40 times 1 over 4 to the second power. Now, 4 times 4 is going to be 16, so it's going to be h equals 40 times 1 over 16. I'm going to make this into a fraction as well. Let's put that over 1. And we're going to have, let's see, this will be 40 over 16 when multiplied. I think I can divide both of these by 8. I think I can. Let's see what happens. Divide 40 by 8, I'll get 5. If I divide 16 by 8, I'll get 2. So 5 over 2. And the units for the height is in yards. So this will be a yard. Now, 5 over 2, just to let you know, it also can be 2.5. So both of those are equivalent.